Hello everyone, my name is Alfonso and this is my key activity final stage presentation. Before we go into the research, I'd like to address a couple of questions, some background questions. First of all, what is viscosity? Viscosity is the resistance of a liquid substance, and the greater the viscosity of a liquid, the slower the speed at which this fluid travels. And now, what is lemonade? Lemonade is a popular refreshing drink, usually made up of water, lemon juice, and sugar, or the chemical name sucrose. The main component of lemon juice is citric acid. Now let's go into the research. First of all, what was the research question? The research question was, how does the concentration of sugar and citric acid affect the viscosity of lemonade? And the relevance of this topic relies on its importance for the food industry and some branches of engineering, like those that have to deal with fluids and viscosity. The user experience is greatly affected by its viscosity when having a beverage, so this is very relevant. Now the theoretical support. There was a study from the University of British Columbia that established a relationship between the concentration of sucrose and viscosity in an aqueous solution. However, it wasn't clear whether the relationship was linear or exponential, or how citric acid may interfere in this relationship. Now to the methodology of my research. First, I'll show you the variables. The independent variables are the concentration of sugar, the concentration of citric acid. Those will be in percentages, and the dependent variables will be viscosity. And control variables are weight, volume of the sphere, volume of the liquid, among others. And as the name suggests, control variables will stay the same throughout the experiment. Now, this is the experimental model. Materials required are citric acid, sucrose, water. These ingredients are in order to make the solution. Also, some measuring devices such as a stopwatch, a flask, a sphere, a scale, and a ruler. Samples with different concentrations of citric acid and sucrose were made, and each sample was poured into a flask. Then a sphere was dropped through the solution, and then the time was measured with a stopwatch. There were 3 tests for each sample, and after that, using Stokes' law, we can solve for the viscosity in Pascal seconds. So the results were gathered by performing the experiment with a stopwatch and notebook to record the time obtained in each trial. So for each trial, I dropped the ball into the flask and waited until it reached the bottom. Then when the ball touched the bottom, I would stop the timer and register the time it displayed on my notebook. And in this table are the results for each trial and for each solution of sucrose and of citric acid. And as you may see, the time it took for the ball to reach the bottom kept increasing, so the velocity of the ball actually decreased. And as Evelyn Kim suggested on her research, I used Stokes' formula to obtain the viscosity of each sample from the average velocity of the ball in each trial. And by using this formula and solving for density, I got the viscosity in Pascal seconds for each different concentration and plotted the results on the graph that is on the right. You may see there is an exponential behavior with the sucrose solution and a more linear behavior with the citric acid solution. So in conclusion, what does this tell us? The data suggests that there is an exponential relationship between sucrose concentration and viscosity. Citric acid seems to be directly proportional to viscosity, but its effects are weaker than those achieved by sucrose. During the experiment, it was observed that the sphere fell slower in more viscous liquids, that is, the ones that had more solids, which corresponds with the definition of viscosity. And the increase in viscosity due to an increase in solids can be attributed to their superior density and a strong interaction between the molecules of the solute. Therefore, the concentration of sugar and citric acid increases the viscosity of a lemonade. On a practical level, however, the effects of citric acid are negligible because there is very little citric acid in lemon juice. But sucrose greatly affects the viscosity and could be used to control the viscosity of other products without using artificial thickeners. One way to improve this research could be by using more accurate measuring devices and a longer flask to reduce the uncertainty of the results. And another way of improving this research would be by increasing the number of trials and the range of concentrations that are tested in order to get a more general view of the behavior of this phenomenon. Thanks for watching. Here are my references.